how would you do these functions if you had an equation here that you didn't know how to integrate? Well, just to make it short and sweet, you could make your own table. So if you're ever given a function and you're using a calculator, which most of the time you'll be able to do, unless someone's put up some really nice numbers for you, really easy numbers. But if you're doing that, you'll use your calculator to find those specific points, and now you can do your own Riemann sums for the left, the right, the midpoint, or the trapezoid by making your own table of values. Now, here's a quick reminder of a little bit of geometry. If you recall, we used to find the area of a trapezoid by taking the average base. That means I add up the top and the bottom base, whatever their size is, and divide them by 2. It gives me the average base times the height. What's going to happen here with our trapezoids is normally they're going to be set up vertically. So now when I look at this, the base is the same all the way up. The two heights might be different. So I find the average height times the base. And that's the formula that I would use to find a trapezoid estimate, or use trapezoids to find the Riemann sums of a certain integral. Now I'm going to go back to using the table over here on the left because the numbers are just much easier. You can use it for any function, but it's just much easier to use these. And once again, I'm going to go back to 4 of them. So that's going to reset exactly how wide each of these are. Take a moment, use the formula for the area of a trapezoid to estimate what the Riemann sum would be for this table of values with 4 subintervals. So here's what I got. For the first one, I have the average heights. Height on the left is 8, height on the right is 6. The average height is going to be 7 times the width of 2. Now, it's just a coincidence that this time the width of the entire trapezoid and the 2 down here will divide out every time. That was just nice, but that won't always work out. Yeah, so I find the average height times the width, average height times the width, average height times the width. I get an answer, 17, there it is. How accurate is it? Well, we do actually have formulas for finding out the error of these types of things, but you need to know the function value. And you need to know how to take some derivatives. You won't need to do this for the AP exam. I may take some time to go over it in class, but it's not something that we need to do in the nature of this course. So here we have it. Now, if you look in the book, you may see something just a little different than this for finding or using the trapezoid rule. So here's why the book has something slightly different for our trapezoid rule. Let's just say we have some generic numbers up here, and it starts at x sub 0, x sub o, x naught, whatever you want to call it. And then it goes 1, 2, 3, 4, all the way up to the final one, which would be x sub n. And then your y values are just that same x value plugged into the function. So I'm using generic values here. But the quick estimate here is we're still going to take the average height times the width, average height times the width, average height times the width, average height times the width. So what they've done to simplify this just a little bit is they said, well, what does every single term here have in common? Every one of them is multiplied by the width. What if I just factored out the width or distributed that out? Every single one is divided by 2 when you're getting the average of those heights. Divide out a 1/2. And now think about what the width of any of these might be. Well, I know up here a minute ago I had it going from 1 to 9, or x sub 0 to x sub 4. Basically, whatever it is, your lower limit to your upper limit, we're going to take the total width divided by the number of intervals. That will tell you the width of each trapezoid. Because we're multiplying it by 1/2, I put the 2 in here. So it's now the total width, b minus a, divided by 2n. The width times 1/2. And then we just start combining everything in here. But if you look at this, there's a little pattern. There's exactly 1 term for x sub 0, but there are 2 terms there for that second one, x sub 1. There's 2 terms for x sub 2, and etc. It goes on the same way all the way down till you get to your last term.